So today we will see about the remaining theory parts in deep learning concept. Okay, so first neural network. So as I told, in machine learning we use algorithm to train our model, whereas in the deep learning concept we go for this type of neural networks to train our model. So network or neural network is nothing but interconnection of both input and outputs with some associated weights. Okay, the connection you are seeing, right? So those are called as the weights. Okay, each connection will have some weights in it, and then by adjusting the weights, our model will start learning. Okay, so it is an architecture, so where each layer is stacked on each other. Okay, we will have input layer, output layer, and uh, hidden layer is there. So all these layers are known as input layers. Okay, starting. Okay, and then the ending last layers are called as output layers, and in between the input and the output layers. Okay, even if you are having several layers also, we call them as, yes, Praveen. uh, okay, we call them as hidden layer. Okay, so if you go in the hidden layer means each is called as neurons, like how human brain will have neurons. Similarly here also we will have neurons. These neurons will be connected with each other, not vertically, whereas horizontally. Okay, if another layer is there, assume like how here you are seeing, right? From input, uh, from each input the network will be passed to all other neurons present in our hidden layer. Okay, so inside the neural layer, what will be there is, if I'm taking the neural network, okay, so inside that we will have some processing will be taken place based on the input we are passing along with the weights. Okay, that I will explain what type of process will go on. Okay, for this we need three things. Okay, first is weight, so it will have some weights, and then uh, second one is bias. Okay, bias is nothing but some additional value will be given to our weightage to tune our model, or make the model to learn from it. And the third one is activation function. Okay, some algorithms we will use to train our neural network. So activation function will be there. So in simple terms, if you want to say, means input is coming, okay, along with the input, some weight will be added to it, and then in the inside the hidden layer only that calculation part will happen, and then after that it will pass to the another layer or the output layer which is present. Okay, uh, so then we will have perspectron. So if we don't have any layer, okay, hidden layer is not there, only we have input as well as output means, then we call them as perspectron. It is used for making simple decisions. Okay, if you go for the classification means, based on this, if you are trying to classify means, if you don't have any hidden layer, only you are having input and output means, we call it as simple neural network. Okay, we call it a simple neural network. In case you are having only one hidden layer and then input and output is there means, we call them as shallow neural network. Okay, shallow neural network. So more than one layer is there means, in that case we will call them as deep neural network. Okay, so as we have seen, this is the human neuron structure. Okay, it will contain dendroids, cell body, axon, and synapses. So similar way, like a human brain, they have tried to create some, take some input. Okay, here in the human brain, this will act as the input part. Okay, and this is where the process will take place, and assume that these are the outputs. Okay, similar way we use some mathematical and activation function to perform this similar type of operation. Okay, so as I told, input is there and neuron is there, right? So if I divide the neuron into two parts, okay, in the left hand side part, it will receive all the input from the previous layer. Okay, here previous layer is our input layer, whereas in multiple layers it will get input from another output of one hidden layer will be input of the another hidden layer. Okay, and the right hand side will, what it will do is it will sum up the input passed along with the activation function. Okay, so the output value which we are getting from the hidden layer is used for making prediction. Okay, you can use prediction. If it is a classification type of problem means you will get either yes or no kind of result, or based on the classes, any precise class it will have. In regression type of model you will get only one output. Okay, some predicted value it will get. Okay, so this is what happen in inside the neural inside one neuron. Okay, like that we will have multiple neurons, multiple times this process will be continued. Okay, uh, so when you come to the activation function part, we have different activation functions are there. Okay, we have step function, sigmoid function, tan h, and ReLU function. Okay, if you come to the sigmoid function, sorry, step function, so here everything is comes under either 0 or 1 category. Okay, this type of function we will use for binary type of classification. So binary classification is there means either yes or no, possible or not possible. That type of cases we will go for this step method. Okay, so here we will not have in between values and all. Either it will be 0, okay, true or false, like that only our output will be predicted. So because of this reason, we cannot use this gradient descent method. Okay, I will explain what is a gradient descent method, but as of now, assume that it cannot be manipulated. Like we cannot pass any bias value to our program to perform some operation. Okay, whatever it is predicting, either it has to predict 0 or 1. There is no in between values will be there. Whereas if you go for the sigmoid function, so in machine learning concept also we might have seen this similar sigmoid function, right? When you are seeing about a logistic regression, uh, right? So what it will happen? It will not go less than 0 or greater than 1. So it will be like a shaped curve we will get, right? So similar thing here also happening. So x value is infinite also, the output is going to be 1. If it is negative also, it is going to be 0 only, maximum and minimum values. Here it will use the gradient descent and back propagation method to train its model. Okay, and we have tan h function. So it is little bit modified version of that sigmoid. So in sigmoid function we have seen from 0 to 1 only it will take, but here the range, it ranges from -1 to 1. Okay, it is used for some better gradient purpose. We will go for the tan h function. Okay, and the last one is ReLU function. Okay, rectified linear unit. So here what will happen is if it is a positive value means it will take as it is. Okay, even if it is going for larger value also, it will take as it is. Whereas when it coming to the negative value, it will make it as neutral. Okay, it will always return the same value, or okay, this is what, otherwise it will return the value back 0 as our value. We also have some leaky ReLU function in that instead of getting the 0 as our value, we can set some default value also. Okay, instead of I don't want to be 0, I want something else means we can fix that particular value. Okay, this is somewhat mostly you can see in our model. Okay, this sigmoid, that and all little bit repeatedly coming. Okay, and so when you go for algorithms of deep learning, we have very few algorithms basic and algorithms, which are artificial neural network and recurrent neural network, as well as convolutional neural network. Okay, so when you go for the artificial neural network, so it composed of four basic principle. Okay, first one is layers. So what are the layers we have? We have input layer, hidden layer, and then the output layer. Okay, and the second one we have is feature and labels. Okay, what are all the input we are passing, that we will call it as features. Okay, whatever output we are getting, that we will call it as label. Okay, and then we will have one more, third one we are having is loss function. Sorry, we will have loss function. So what this loss function will do is, we are predicting some value, right? It will try to compare with the actual value and how much loss we have got, like similar like finding the error. Okay, here we are calling it as loss. Okay, actual value will be there and predicted value will be there. Both value will be passed to our loss function, and then it will say this much error you got, like that. Then after finding the error, it will go to the optimizer. Okay, we have optimizer. In that only some decision will be taken based on the gradient decision algorithm. We are seeing the term, right? So that gradient decision algorithm only will take decision what value we can add to our weights. Okay, I have the flow diagram in the next slide. I will show it. Okay, these four are the main principle available in our model. So then what else, for what and all we can use this particular artificial neural network is, so mainly for training non-linear type of functions. Okay, if you are having non-linear patterns, means it can able to easily identify the complex relationship between the input and output, even if it is a non-linear type. Okay, that is one advantage. And another thing is weight. So based on the weightage, it will change. Okay, which means input is there. Okay, some value is there, assume. Okay, each connection will have some weightage. Okay, so what this function will do, I have told, right? So input as well as the weightage will be multiplied with the uh, so RF. Okay, recurrent function. So in that sorry, activation function, not recurrent, activation function, based on that it will do some calculation. Likewise, each neuron is doing, and then some output is coming. Assume that some 50 is coming as my output, but my actual value is 60. Okay, so these two values will be passed to my loss function, and then um, it will go to the optimizer stage. In that stage, it will add some bias to it. So we have seen, right, we have weightage, bias, and other things, activation function to perform the operation. What it will do, it will increase our weightage, increase or decrease based on the output we are getting, difference based on the difference. So assume that I am adding some two more bias, like adding two values to my weightage, like that each weightage will be changed. Then again it will perform the process and check. Okay, next time when I'm doing, I'm getting 55, means again the process will happen. So slow, I mean, step by step it will try to improvise our model. So this is what will happen. But at some point of time, okay, even in the training time, we can able to make it perform like we can get 98 or 99 percentage accuracy. But whereas when you are giving some testing data, it will not perform as expected. Why? Because based on the knowledge we have given to this particular network, it will reach some certain point where it cannot able to learn more, it cannot able to improve its knowledge further. So in that case, we have to change the knowledge, or we have to retrain from the beginning. Okay, then only we can get some optimized or expected output. Okay, closer to the actual value. So so feed forward neural network means it will work in the one direction only. So input will be passed and output will be given. So no other repeating will not happen here in the artificial neural network. Okay, this complete process is there, right? This is what we call it as one epoch. So in yesterday also I have shown on website, right? Here also, I mean, there also you might have seen the epochs. You have seen everything is similar like this only. So one epoch means starting to end. One time it is running, right? So that is called as one epoch. Afterwards, I'm told, right, the loss function will be there, and then optimization and all happening here. That and all will, after doing that, again the process will repeat, right? One output I'm getting as 50, and then I'm doing some loss function and optimization, and then I'm going back to again the input, right? So this process is called as backward propagation. Okay, so how many times you want to repeat this process based on the epochs we are specifying. uh, I'm specifying 50 times I want to do that, means 50 times this process will be continued again and again. Okay, until it get, I mean, for each output it will, we will get some different output, right? Based on that we will select which is giving the optimized value, maximum optimized value. Okay, so this is the flow diagram. I think here you can understand it even more better. Okay, input I have given, so it is passed to my first layer. Okay, in this layer some weights I am adding to it, and then uh, after doing the operation, second layer it will go. Okay, this output is passing as input to my second layer. Again some weightage will be added, and then it will predict one value for me. So this is predicted value and this is the actual value. So both will be passed to my loss function. Okay, here some calculation will happen, like either we will find mean square error or any error is there, means that method we will use. Different methods we have to find that. Based on that we will pass the output to our optimizer. Here only I have told we will use the gradient descent algorithm, right? So here what will happen? It will try to update our weightage. Okay, so it will perform well if it is in, if the gradient will grow very smaller based on the layers. Okay, how deep the layer is, based on that our value also is going to change accordingly. If at certain point of time what will happen, the gradient value will stay constant. Okay, it will not increase or decrease. In that case we can say that our performance it has reached the maximum performance, it cannot able to further learn or do anything more. Okay, in that case we will stop the process. Okay, so that is what you also mentioned, like some input values will be passed and then it will pass to the fully connected layers, and then some learning will happen, and then testing with new knowledge. So first it has predicted with one thing and I am passing one new value to it. So each time when it learning, right, it is called as knowledge, it is gaining some knowledge. Based on that it will try to learn something. Okay, the program will repeat this step until it makes the lowest error possible. Okay, it will not know sometimes when to stop or anything. So based on the outputs we are getting, we will, we can able to come to some conclusion. Okay, at this particular point of time we are getting some good accuracy, so we can stop the process at this stage itself. Like that we will decide. So in some cases it may not able to predict exactly, like for example your expected value is 55 some. Okay, and then it will be showing like 53 or 54 or 55.7, like that. If some ranges showing, means this pattern will be repeated. Okay, if you are checking the outputs, so in that case we cannot able to attain our maximum expected output. In that case we will either go for this predicted value or the this predicted value. So like that only our what to say, our neural network will start learning. Okay, any doubt in the ANN method? Okay, so we are just seeing the theory part only. When we go for coding other things means maybe you can understand the flow even more better. So as of now, this is the concept of ANN. This is how uh, step by step the process will take place. Okay. Okay. Next, we are going for the RNN method. So, which is nothing but recurrent neural network. So, if you see the network means, so it is also looking similar like the traditional neural network, right? Except only thing is we are having some loop over it, correct? So, looping system done in the AA is known as RNN. So, same ANN only, but only thing is each hidden layer will have, each neuron will have some looping system. Okay, based on that only we are calling it as RNN. Okay, recurrent neural network. Here what will happen is each neuron will have some memory. Okay, so whenever the process is happening, right, from the input we are getting and some calculation we are doing, that will be stored in that particular memory. Instead of going to the output layer, like going to the next layer, the output of one hidden layer will be passed as input again. Okay, this process will be continuing repeatedly, okay, for n number of times. So that n, how we will specify is, how we will call it as time step. Okay, we will specify some time step. This many times you try to run your code. I'm saying 10 times you do means. So first it will get some output. So that output will be passed as input. So like that 10 times it will repeat the process. Then only that output will be passed to our next layer or the output layer. Okay. So uh, So another thing is it is based on the sequential information. It will try to predict our output. So for example, we have many cases of RNN, like it is used in text analysis. Like you are nowadays for searching, you are using right search engine, or even in keyboard when you are typing, based on the keys you have pressed, it will giving you suggestion, right? So all these are based on the previous output, right? So that and all possible you based on the RNN method. Okay, so text analysis we can use, image captioning. Okay, if you are passing on image means it will try to read the image and it will give you one caption for it. For that you can use sentiment analysis based on the text. For customer services and all, they will use this type of algorithms. So based on how the user is responding, okay, the words the customer is using, whether is in angry mode or anything, we can detect. Or even if you have used the website like Grammarly or anything means, that will also give you some suggestion like excellent, or positive, negative, like that. It will show you some graph. Okay, all these are based on this type of recurrent neural network only. So based on previous uh, data you have typed, it will give you some suggestions. Okay. Okay. What type of problem we will face in this recurrent neural network is based on the time step only we will face the problem. Why? Because here if I am giving 100 instead of giving 10 times, I am giving 100 times. Okay, loop over the same neural network means, assume that I am having 10 hidden layer like this. Then how much time it will take to process? It will take more time, right? So even it can become like untrainable model also. That type of possibilities are there. So in technical term they call it as vanishing gradient point or gradient problem. Okay, that there is a possibility of occurring that. So so we should be careful in handling with the time step. So for that only, to overcome that challenge only, what the developer had made is they try to implement one new concept of long short term memory. Okay, so this will help us to solve the vanishing gradient problem. So what it is do is it will have some strong architecture. Okay, based on that, it will not if even if I'm giving 100 times loop also, it will it will have the older data, okay, for temporary time. So it will try to compare the older data with the new data. If the patterns are getting matching means, in that case it will not repeat the time step process, it will skip it and it will move to the next layer. So in this way we can overcome the vanishing gradient problem. Okay, that is one thing. So this is mostly used for natural language processing, as I told, right? Based on, you can use it for voice also, like if you are training a model, AI model or something, okay, based on the text, voice, you can detect the sentiment of a person, or you can even detect whether it is a spam mail or a normal mail. So everything can be done using this recurrent method. Okay. Our TensorFlow also is having this recurrent neural, our TensorFlow is having the long short-term memory architecture. Okay. Any doubt in the RNN method? Okay. Then we will go for the third algorithm, which is CNN method. So convolution neural network are very famously called as a computer vision application or OpenCV. So whatever projects you are seeing based on the image or video, that comes under this convolutional neural network concept only. Okay, so it will try to predict some features out of the picture or the video which you are passing. Okay, it can be a live or already taken videos. So it will try to capture the specific features where ANN cannot do. Okay, and also in our CNN model, we don't have the recurring neural network also. Okay, the time loop, that and all will not be there. Okay, it completely uses different method, which is called as convolutional type of hidden layer. So completely different pattern of hidden layer will be there when comparing to ANN and RNN. Okay. So, okay, to understand it better, if you think of an Facebook, okay, few years before, if you are going means, whenever you are posting one image, okay, it will ask you to name, okay, if in the image two three friends photos are there means, it will show some marking, it will ask you to feed the name of the person, you have to manually tag those person. But nowadays, whenever a new image is posted in the Facebook, it will automatically detect your face, along with the face it is showing your it will show your name. If you click that name means, it will redirect you to your profile also. That type of advancement has been came, right? So uh, all these are possible because of the convolution neural network only. Okay, um, here we uses two different things, which is called convolution. Okay, for filtering the image, if you are giving one complete image, okay, to test means, it will filter some. It will extract some information about the image, and it will create one new image out of it. So output image it will create, and then it will use polling method. Okay, polling method means the image will be converted into matrix format. So from that matrix you will it will take some maximum value out of it. So I will show so that you will understand. Okay, from this example you can understand. So here I have taken, assume it as grayscale image. Okay, why we go for grayscaling method is, grayscale will have only one channel. Okay, whereas if you are going for color image means, it will have three channel. So three channel means red, green, blue is there, right? So those three are called as the three channel. And image is what? It is nothing but an array of pixels, right? So we also say I'm having 32 pixel or 64 pixel, like that we are saying, right? So which is nothing but a matrix of pixel with some height and width, correct? So in our model, how it is taking is, all these zeros you are seeing, right? So it will try to convert the values of grayscale images to 0 to 1. Okay, if it is 0, completely 0 means it is considered as white, and if it is 1 means it is the darker area. So this is not a blurry image. Okay, actual image was initially will be there. Okay, and that image will be converted into matrix format. So highlighted area are the darker images. When you try to convert this particular matrix into an image format using matplotlib or anything, means at the time you will see image like this type only. Okay, even if you are drawing some lines, means this is how it will image will look with some different weightages. Okay, so here normally the range will be between 0 to 255. Okay, normal image size, but here we are converting into 0 to 1. Here and all, if you are seeing, means 0.9, 0.5 is there, right? So that and all having less darkness. So the points having the more darkness, it will take into consideration. Okay. Um, are you all getting the point? Okay. So again, the main reason for going for the grayscale image is to reduce the size of the image for increase the processing speed. Okay, so let us see the architecture. So this is the complete architecture, okay, of our CNN model. So it will be a little bit not more complex, but in simple terms, images has been passed. Okay, some processing will be happening here. Okay, this is the area, all the process will happen here, and at last we will get some classes. Okay, okay. Mm. So here why we are going for CNN method instead of some traditional neural network, I mean other concept is here assume that you are having one image. Okay, inside that image you want to extract the face alone. Okay, or image of any animal or image of any object. So that can be easily achieved using the CNN model, whereas in other traditional method, all the images, assume that your image is there, a face or something is there, background some other mountain or any cloud image is there, means it will give weightage for all the pictures it is seeing. Okay, it is for them, it is all our values. But in the CNN method, we can extract, okay, I want face image alone to read. Okay, I want this type of object image alone I have to read. Like how we have seen in the mask, everything. We didn't specify anything, but based on the inputs we have given, it is try to find the model, right? So these people are wearing mask. So this particular area we need to focus on. So people, if that area, I mean, if people are wearing mask but not on the face, means it should show like no mask. That and all will be trained based on the CNN algorithm. Okay. Uh, so here what is happening is a complete image is there. Why this number 28 into 28 into 1 means? So as I told, 1 is the channel. Okay, we have only one channel because it is a grayscale image, and I have taken 28 into 28 like width and height of one image. Okay, and written 2 is there, like that assume. Okay, however, data is going to be processed like, assume that it will be converted into matrix format. Okay, I think in next slide. Okay, it will be converted into matrix format. Okay, like how we have seen in the previous slide. Okay, and with this itself, I will say, assume that here instead of 1, 2 is there. Okay, like that is there, assume. So what our model will do is it will try to take one portion of the matrix and it will try to perform some operation. From that portion, it will again reduce the dimension and it will check. So like that only, what it will do is assume that from 28 into 28 pixel, it has been converted into 24 into 24. Again, it will be converted into 12 into 12, 8 into 2. Like that, 4 into 4 size, it is has been reduced. It is nothing but the matrix format. Okay, so this portion alone it has taken. Okay, so by this, what it will do, our recurrent activation, what it will do is, it will try to give some weightage to our classes. Here, how many classes we will have? We will have 10 classes, right? From 0 to 9 we will have. So we are having 10 classes. So assume that I have given you an image of this particular portion alone. So what you will assume, what digit you will be assuming? So it can be 2, correct? One possibility is there. So assume that our model is giving some 5 weightage to it. Okay, and then 9 also will be matching, correct? So again it will give some weightage to our this particular class. 0 also will match, so again one some weightage it is giving. So like that, even more possibilities there are not. Yes, we have 3 is there, we have 8 is there. Okay, all this will if I'm checking this portion, okay, and matching with all this means all will get some weightage, like signal will be high, right? So assume that I have given weightage of 5 for this also. Okay, in next step what it will do is it will try to take this particular portion. Okay, if I take this particular portion and check means, again there is possibility that 0 also, this digit can be 0 also. So again this will also get some weightage. Assume that now it is 10. Okay, 2 also will having the matching button, so again it will get 10. 9 also having 10, 3 also having, 8 also having. So all are again getting some extra weightage. Now what I am doing, I am taking this particular portion. Okay, now I will again compare with my classes. So if I come here means this is not matching. Here we don't have any like bend value, right? So this will not get any weightage. So here possibility is there, so it will be like 15 now. So 9 is having a little bit different uh, curve, not like similar like this, so it will also not get any weightage. So 3 is having same curve, so again this can also get some weightage of 10. Okay, or 15, anything. Okay, 8 can also get 15 weightage because that is also having same curve is there, bend everything is there, correct? And then if I'm going for another matrix means, at the time like this only, each time it will take different portion of our matrix and it will perform some operation. Okay, and then it will weight our model. So finally what will happen, this this two class will have the higher weightage, right? So this class will be activated, whereas others will be have less weightage, so it will not be activated. So it will predict as the given input is 2, like that it will show. So to understand it more better, so what we can do is I will say parts of one object. Okay, and you have to say me what are all the possibilities are there. Okay, what can be the object is. Okay, can we do that? Okay. Uh, Assume that I'm saying the object will have wheels. Okay. Now, what are all the objects you are coming into your mind? You can say multiple objects also. I'm saying I'm having one object and that particular object is having wheels. So, what are all the possibilities are there? Is everyone there?
Yes, sir.
Hmm. So, it can be car then. More.
Again,
What
sir.
else? Huh? See,
Again.
I have one. Okay, bus, airplane. See, I'm having one object,
The slide,
Sandeep.
slide, is not, slide not available.
Yes, yes, I have stopped sharing the slide. I just want to discuss. Okay.
Okay, sir.
Uh, so what I'm having on image, assume. Okay. So in the team, I'm having on object, not image. Object I'm having assume. Okay. I'm saying each part of the object. So you have to assume what it can be. Okay, so first thing I have told is that particular object is having wheels. Okay, and there are multiple possibilities are there. Like Ame is giving lot of options like car, bus. So aeroplane is having cycle, motorbike, skateboard, everything is having. Okay, so assume the like each got 1 point like that. Assume. Then next I am saying it will have only two wheels. Now what are all the possibilities are there?
Cycle, scooter.
Cycle, scooter. Okay, like that will be there. Okay. Now I am saying it is having handlebar. Handle is there. Handle is there. Then,
Frying pan.
huh?
Handle. So it could be
Like what you will
like
say actually.
frying pan, bag.
Okay, it is having seats. Okay, seats means again it will come under cycle or bike, right?
Yes, sir.
So,
Chair,
uh, hmm?
chair also.
Chair, wheelchair, like that you are saying. Ah,
Yes, sir.
okay. Now I am saying it is having pedal. Then,
Pedal. So it is a cycle.
ah, so first when I'm saying with lesser clue, you are coming up with different options, right? So when the number of clues getting reduced, your options are getting reduced, and at one point of time, you can able to conclude that it can be a cycle, right? So
Yes, sir.
similar thing only our model also will try to do. Okay, so now if I show this means you can understand. See, what our model will do is the entire image will be taken into bits and pieces. Like our entire cycle, I'm passing it as an image means it will try to split them into multiple pieces, and then based on the different options, so it will try to come to a conclusion. When I say only wheels, it can be a four wheel, two wheel. Okay, multiple possibilities are there. So when I'm getting two wheels, so the options are drastically reduced, so there is less possibility that it can be a cycle or bicycle. So again I'm going for seat means this type of seat only cycle will have. Okay, if I got this first means we will come to a conclusion that this is not a bike. Correct. But I'm saying some handlebar is there, similar like bike. Okay, in that case, again, we will still remain with the confusion, right? Whether it can be a bike. Here, they are having different handle. In case similar type of handle is there, means again, we will go for next option. Okay, when we are finalizing, when you are seeing the pedal and other things, okay, we are pedal and seat means we are coming to a conclusion that it is 100% 100% cycle only without checking other options. Okay, similar way our convolution network also will what it will do instead of checking the entire matrix, it will try to take each matrix. So this the process will happen here. So I'm having the input image is there, it is converted into matrix, right? So it has been converted into 3 by 3 matrix. So like that, it will do some calculation and it will create some new feature. So extracted feature. Like that, it will create some new matrix. From that, it will try to predict the model. So if it is not possible means again it will try to go with another iteration. Like that only you are seeing multiple iteration like right. So this is kind of one iteration and then again one hidden layer or you can say okay. So likewise, it will try to find. Okay, here polling. What is maximum polling is from the input layer. It has created one new layer, right? From this, it will try to create another one small matrix. Okay, 2 by 2 matrix. It is creating. Assume. Okay, what it will do? It will take this four values and it will try to take maximum value. Here, maximum value is 4. So it will take 4 and then again it will create another matrix here. Here also 4 is the maximum value, right? So likewise it will create another matrix and specific feature it will try to get. Okay, here if you go means again 4. So as per our example, all value will get some 4, right? So likewise it will try to extract the feature from the entire image to make our process even more faster. Okay, instead of searching for entire image. Okay, understood. So how this is achieved is based on the simple soft matrix classification method. Okay, so just see the formula here and then I will explain in the next slide. So here X is our the image which you are going to pass and then Y is going to be the weights and then B is going to be our bias. Okay, and based on that we will get some predicted output. Okay, so here in the first step what will happen is the image which we have given 828 into 28 is there, right? So which is nothing but 784. So 784 pixel will be arranged in a single row. Okay, and then it will be passed to see each row will be passed to sorry, each column, it is column, right? So we will have 789 column and then one row. Okay, all these columns will be passed to the 9 classes which we are having. Okay, likewise, what we will do is we will take 100 images like that. Okay, the simple two image itself, different way, like how human will write, like everyone will not write two like this, right? Some will write like this, some will write like this, some will write like z and all. Lot of possibilities are there, right? So even some will write in a different way also. So some people will have a habit of writing like this. Like this, I will pass 100 image, okay, in a single matrix. Okay, each row, how many column is there? So 100 rows are there and 784 column is there. So, and then how many classes we are having? 10 classes we are having, and we will create 784 rows to do the dot product, okay, with this two matrix. So here what will happen is this 784 and this 784 will get cancelled. Cancelled in the sense, after doing the dot product, the output will be in the format of 100 into 10 matrix format. So we know the formula, right? So m into n matrix is there means, and you are trying to multiply with n into m means the output will be in m into m format. Okay. So similar thing happening here also. So this is what mentioned in the formula also. So 10 into 100 into 10 is there, right? So x is my 100 into 784, which is going to be my input, and then weights. So 784 into 10. Okay, that many classes, 10 classes we are having. For each class, we are getting 784 columns, right? So that is going to be a weightage. Plus BIOS is whenever it is completing one epoch. So it will, if it is predicting, instead of predicting it as 2, it is predicting like 3 or anything means, we will try to add some BIOS value and then we will try to tune our model. Okay, this is not 3, it can be 2. Okay, like that we will pass some more values to our model. Okay, in this way only our process will be carried on. Okay, so feed forward, backward propagation and all I have told, right? Feed forward means if it is going in only one direction and the process stops at the output means we call it as feed forward, and the weightage which we are getting, right? uh, we are finding the loss function and then repeating the process. So that is called as we are calculated the error, okay, between the predicted and the target value, and then we will update the weights and then we will rerun the process, right? So that is called back propagation. And then the gradient descent means the algorithm which you are going to use for the optimizing, uh, what bias value we can give to improve our model. Okay, learning rate. So this also we have seen in yesterday class, right? So what all we have seen, like yesterday class means in the website, like at teachable machine we have seen, right? We have epochs, batch. Okay, uh, here if we ask for batch count means 100 images are passed at the same time. Okay, here batch is like single batch, it is updating. If I'm giving like batches 2 or 3 means, based on that it will pass, instead of passing 100 images at a time, it will pass 10 images, and then it will try to train. Okay, for 10 image I'm passing, all are 2 only. Okay, it is predicting as 3 means some bias it will add, and then again 10 images I'm passing, in that it may be predict 2 as 2 correctly, and again 10 images, at the time it is predicting as 8, so again some bias will be added, so to tune our model. So like that this process will be continued, so that is called batch processing. Okay, so learning rate also will be there. Here we will be facing two type of problem. One is vanishing and another one is exploding gradient problem. So vanishing problem where we have seen in the recurrent neural network, right? So the value at, after some certain point of time, the value cannot be used. So it will attain some certain constant value. So it will not increase or decrease. So in that case, we cannot train our model. Similarly, uh, if you are using like sigmoid or any other model means, after some point of time our model also will not increase. Okay, when you are trying to decrease on certain point of time, it will not decrease, that is called vanishing. After some point of time it will not increase, that is called exploding gradient problem. Okay, so that is what given in the like theory part. Okay, again both type of problems can be solved by using long shot method, memory network, and the gradient clipping method. Okay, so up to this any doubts is there? No doubts. Okay. So, so what are all the things we have seen? Like just a summary I'm saying, and I will complete it. So first thing we have seen as neural network. So in that we have seen classification like simple, shallow, and then deep neural network. So if you are having only input and output means, so we can call it as Perspectron also. Okay, for simple decision making. And then so similar like human neural network, we also have the neurons. So inside the neuron, what will happen? Two process will be there. One is for two sides. One is for getting the input, and another is for doing some calculation and passing the output based on the activation function. And what are all the activation function we have seen? Step function, sigmoid, tanh, and ReLU function. So step means 0 and 1 used for binary classification. So sigmoid again to avoid uh, linear type of problem, we can use go for a sigmoid method. And then tanh function, little bit modified version of sigmoid. And then ReLU function. So we have leaky ReLU method also. And then what are all the algorithms we have seen? Artificial neural network, recurrent neural network, and convolution neural network we have seen. And then in the artificial neural network, we will have some simple architecture. So no any recurrent values will not be there. Only forward propagation only will be there, or forward feed only will be there. Correct. So and then this is the flow chart. Like once the value is predicted, it will be go to the loss function, and then optimizer will tune our or update our weights, and then again it will pass to the layer. Again some class calculation will take place, and again prediction, comparison, everything will happen in our model. So in the ANN model, if you are adding the recurrent means, which looping means, we call it as RNN. So this is used in most of the cases, mainly for natural language processing. And then if we come for the CNN means image and video, other things we can able to use it. Okay. So here we are using different hidden layer other when comparing to RNN and ANN. Okay, here the ANN cannot do the special feature which have the CNN. Here we call the process as convolution process and polling method. So the images which you are passing will be converted into matrix. Okay, and whichever the darker area is there, and image will be converted into grayscale for a faster optimization. And then in our architecture, each matrix of image will be splitted into small uh, matrix, and then it will try to predict our model. Here we are having 9 classes. In some cases, if you are instead of going for number, you are going for alphabets or anything means, we will have even more classifications, right? So this is how it is trying to predict. Based on some identification, it will try to come to a conclusion. Okay. So how it is possible? Based on the simple softmax classification method formula. Okay, our so first it will be in the image format, then it will be converted into matrix format. So matrix will be converted into multiple rows. Some dot product is happening. So if it can't able to predict means, we will add some bias to update our weightage. Okay, so uh, when I was searching for some website to show you, I come up with this particular website. Okay, similar like yesterday we have seen, not exactly like that. There we can able to create our model, but here in this website, so if you see means platerecognizer.com. Okay, if you go means here also they use CNN method model. Okay, to predict the number plates. Okay, not only number plate, it will try to find the model name, color, what company it belongs to, everything can be done by here. So to find that, what I did is I randomly typed searched for some images. So this image, this bike image, all this I have taken and then I have uploaded it and checked. So it is predicting it. So let us see this particular website. So I will share this website also. Okay. Here I'm not sure about the pricing and other things. You can simply upload one image and you can check whether it is predicting or not. So I have downloaded 2 3 images. So first I will pass the car image. Okay, see, it has automatically predicted this particular area alone, and it is giving me the exact number, I mean the digit, character, everything it is showing it to me. As well as if you see in the right hand side, it is showing, see how much prediction it has made. So plate candidates, so DDKY612 is having 89.80% prediction it has got. Okay, and the second one is having 6L, I guess. It is not 1, it is L. That is having the second prediction. So 77 percentage, 77.70 percentage only is there. So we can say first prediction itself it has predicted correctly. And the region, so it is confident level is 86.10 percentage. Okay. So and then Mercedes-Benz. So here if you see means 36 percentage, it is like Mercedes-Benz. Like I think different three options also it is having. Among that 36.30 percentage, it is confirming that this belongs to Mercedes-Benz, and then what model it belongs to. Okay, again it is giving you various options. Maybe it can be wrong also. So if it is wrong or you are not satisfied with the output means we can inform to that if you are like feedback if you are giving means based on that they might have improvised the model, I guess. See, it has predicted it is white in color or silver in color or brown in color, because we have almost like 3 colors, right? Like here and all little bit brownish, here brown is there, a little bit blackish red or something is there. So more number of options goes to white, so it is predicting it as white color. So if in case it may not be white also, it can be a silver color also, but it is showing you multiple option. And then it is a rear image, see, rear or front or unknown, so that also it is showing you how many percentage is there. So it is accurately predicting that it is a real image. Like this also you can create some CNN model, not like predicting the number plates. If, or if you have some database of a lot of vehicles or Indian vehicles, or in your region any workshop is there, in that you are able to collect the information means regarding that also you can make, like how in traffic signal they are trying to track our data. Like if you are trying to pass the traffic signal without before getting the green signal, so you automatically it will scan your number plate and it will send one you know uh, fine to your address. So like that and all nowadays coming, right? So all these are this type of prediction only. So I try to pass another image like bike image also. So that is also it is predicting. Okay. So it is a some uh, so here if you see means it cannot able to predict whether it is a front or rear, but actually it is front, right? So front is having very less percentage only, but unknown is having higher percentage. So like that it will show you some output. Here it is not completely white color, right? So here color is not properly visible. Maybe based on the number plate color it is predicting. Okay, region India. Okay, maybe MH. Based on that it is predicting, I guess. And then here if you see means 4 different possibilities are there. So it can be uh, 0. See here it is 0, right? So it is giving you different option, like it can be 0 or O, like that it is giving you option. So it is, we can say 85% is predicting correctly. Like this also you can create, whether yesterday we saw mask image, right? Similarly you can track that, we will say like marking the data. So how it will happen is for training purpose, if you are trying to create your own data set from the scratch, in that case we will have some software or anything. So in that what they will do is if you are taking 10 image means each image you have to mark the area, which particular area alone you want to predict. So here, how they might have trained this by passing like 1 lakh images of number plates alone, both car, bike, they will pass it. So based on that, it is trying to extract the data out of it. Okay, this is even you might have seen in some projects like live detection also will be there. So that type of project also you can do instead of just uploading image. So lively it has to track your either you are wearing mask or not, you are wearing a helmet, or you are following the traffic rules or not. Like that also you can create some projects. Okay, it's totally up to you. So hope you all understood. So tomorrow also you will be having a normal session only. So tomorrow I will start TensorFlow. Okay. So that's all for today's class. Any doubt is there? Yes, Sandeep?
No, sir.
No doubt. Okay. Then thank you. See you on tomorrow class.
Tomorrow. Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Hmm.
Thank you, sir.